Hi, welcome to this podcast on hexadecimal for the OCR Computing A-Level F451 unit. So what is hexadecimal? Hexadecimal is a base 16 number system. So what we have is 16 numbers ranging from 0 to 9, which is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. That's your first 10 numbers. Because we've already got a base 10 system, which then would go 10, 11, 12, 13, we can't use that. That's because they will get confused when you're looking at the number representation. So what we use instead is letters to represent 10, 11, 12, 13, 14 and 15, which would be your next set of numbers. So we've got A for 10, B for 11, C for 12, D for 13, E for 14 and F for 15, and all of that together with 0 makes 16 numbers. So how do we therefore represent a hexadecimal number? Well, what we do, we have the same as we had before. When we were using binary, we were using base 2, which meant the first number was 2 to the power of 0. We are now using base 16. That means we're going to have the first number on the right hand side there, which is 1, is 16 to the power of 0. So 16 to the power of 0 is 1, as we know. Then the next number will be, instead of being 2 to the power of 1 as binary was, it will be 16 to the power of 1. 16 to the power of 1 is 16. So the next number will be 16 to the power of 2. 16 times 16 is 256. The next number will be 16 to the power of 3. 16 times 16 times 16 is 4096, and so on. This will carry on as however big your hexadecimal number will be. So if you have a look at the number here, which is 1 and 0, what would that represent? Well, we've got 1 16 and 0 ones. So in hexadecimal, that would represent the number 16. So 1 0 in hex would be 16 in denary. So if we then look at another example, so we've done that one, 1 0 1. So if we go back and have a look, 1 1 on the right hand side would represent 1. 0 16s would obviously represent no 16s, and 1256 would be a number there again. So we've got 256 plus no 16s plus 1 at the end equals 257. So 101 in is hexadecimal in denary would be 257. So what happens though when we have letters? Now obviously we talked about the letters, and the letters represent 10 through to 15. So F represents the number 15. So when we look at this again, we've got 256, one of those plus no 16s plus 15 ones, because we've got an F there. So that would equal 256 plus 15, which is equal to 271. So 271 denary is represented in hex as 10F. Right, so that seems all a little bit difficult. Is there an easier way to do it? Well, yes, there is. As we found out with octal, we can actually do this using binary representation from denary. So first of all, we've got an example here, a number 36. What we're going to do is represent that as a binary number. So the binary of 36 is 00100100. So that's a 0 number of 1s, a 0 number of 2s. The next digit there would be 4. So that's 1 4, 0 8, 0 16, 132. So we've got a 32 and a 4 is equal to 36. If you're not sure how I did that, then please look at the binary representation to understand this further. Then what we can do is split it up into the nibbles. So from the right hand side, we're going to split it up into 4 bits. And then we go across and find the next 4 bits, and so on if it was a very big number. In this case, we've only got 2 nibbles, therefore we've got 4 bits on the right and 4 bits on the left, and we then work those out into a denary value. So from the right hand side, what we've now got is we're just going to represent that. If I just use the mouse to point it, we're going to represent this number as a simple denary, and then we're going to ignore this side and then just represent this binary number, the 4 bits here, as a simple denary. So here we've got 0 1s, 0 2s, 1 4 and 0 8s. So that equals 4. here we've got 0 1s, 1 2, 0 4s and 0 8s, so that equals 2. So now that will represent our hexadecimal number, which is 2 4. Alright, now if we can just double check that, down here we've got a 4, 4 1s, and 16, 2 16s, so 2 16s is 32 plus 4 1s is 36. So it's actually very simple to do. Similarly, if we think about this here, the biggest number that this can represent is 15. So if we ended up with 1, 1, 1 and 1, we'd have 15 here. And what we'd then do is represent that, instead of as the number 15, we'd represent that as the letter, which would again be the letter F. If you're not sure, if you want to double check this, then go back and try and work these numbers out again, and then try and do them using the binary representation as we've just shown a moment ago. Okay, I hope that helps. That's hexadecimal for you. If you got a little bit confused in the middle, as I said, watch the binary video first, because that obviously makes it a lot easier to understand if you know the binary, and you need to know the binary to understand the hex representation using binary numbers. Anyway, as I said, I hope that helps, and please come back for more. Thank you.